Hey, good morning, guys. Mr. Rajani here. As you know, I am out of the building today at Butte Elementary, helping out Mr. Rocky, learning some of the ropes, and getting my Valentine's Day experience with some of the littles. I'm pretty excited. Hopefully, I get some candy grams or something. I don't know if they still make those hearts with the different sayings on them, but I'm a candy fiend. So hope you guys are having a great day. Just wanted to give you a quick little short video here on what's going on. This is not something that will take us the entire class, but I wanted to make sure that we had the opportunity to move forward just a little bit with some things kind of coming up. And we do have a couple labs that we're going to get into next week, and just want to make sure we're staying on track with everything. So real short task for you guys today. Appreciate if you could get this done, kind of before maybe working on anything else, or practice rounds of the game. I know some of you are really into that, some of you aren't, but we'll need to do something really short in Canvas. So if you were to go to the module section, you guys are all familiar with where that is, and scroll down. Again, my screen's going to look a little bit different than yours because I have the teacher view and some things hidden, but at the very bottom of our current unit that we've been on, motion of objects, down at the bottom there's something called other simple machines. I'd like you to open up that link in modules, and you're going to see a little data table here. And I'd like you to create your own version of this data table in your journal. It's something that you're going to need to be able to write a little bit in. So if you want to basically take up an entire journal page, that might not be a bad idea. I do have rulers in the box underneath the computer monitors in the back. There should be some rulers with like some glue sticks and scissors and various boxes of things back there if you're a neat freak, which I know a couple of you are. Basically what we're doing is we're trying to look beyond the one simple machine that we've discussed so far, which is the lever. So we've been focusing mostly on levers and different classifications of levers, and I got a little definition given for you here about a lever. Basically is just being this rigid bar, so basically a bar that doesn't move, but it is free to move around some type of rotation point or a fixed point that we call a fulcrum. So we talked about class 1, class 2, class 3 levers. We looked at some examples, teeter-totters and scissors and nutcrackers, and even parts of the body that function as levers. And I think you guys are doing a great job understanding the difference between those. Okay, and then we also talked about how we can find mechanical advantage of a lever, and there was a couple different ways, and I put one of those in that box where we can use a formula to divide the length of an input arm by the length of the output arm, and that'll give us something called ideal mechanical advantage. And we know that the greater the mechanical advantage is, the more a machine is helping us do something with a force. So, for example, if I solve a problem and I come up with a mechanical advantage of 4, that machine is making our force that we apply 4 times greater, or it's a factor of 4. So machines are very, very helpful in that regard, but levers are not the only type of machine. So what we've got here on this data table is some other types of simple machines, things that we come across in everyday life and maybe don't realize it. So we've got wheel and axle, the inclined plane, the wedge, the screw, and the pulley. And so we've got a couple different resources we're going to work with today to try to complete this data table in our journals. The first one up here is a really, really, really simple PowerPoint that I put together, where there are essentially 6 slides in the PowerPoint, and on each slide it shows you a picture of each of those simple machines. It might give you a basic definition, it might not, and then it might tell you how to solve for mechanical advantage on some of them, and it might not. Okay, so one place to look is there, but you're probably not going to really get all of the information just from the PowerPoint. Another fantastic resource is our textbook. Okay, and so I know that's not something that we use very often, but textbooks were these things that they used to have in schools back in the day, and they're full of these paper pages, and they tear really easily, and people draw on them and stuff, but sometimes they come in handy for building ramps and standing on to reach higher places. But for today, we're going to try to get some information from them. So if we were to turn one of those pages to one of those books, to pages 427 to 433, we're going to see a little bit of information about each of these simple machines. Okay, and it's going to tell you in there a definition, and it's going to tell you how to calculate mechanical advantage, but it might do so in a language that maybe we don't fully understand. Remember, putting down a definition word for word isn't any good unless we understand what it's saying. So I definitely encourage you guys to talk about those definitions amongst people in your vicinity, at your tables, people that you typically group up with. See if you can together maybe simplify some of those definitions, or maybe between the textbook and the PowerPoint come up with a shortened version of a definition or explanation for mechanical advantage. You do not have to put all of those other ways of finding mechanical advantage on your formula page, okay? Some of them do have formulas. We're not really going to get much beyond the formulas for the lever, but I want you to be able to put, at least in word form, how to solve mechanical advantage. So for example, with the wheel and the axle, okay, it's going to have to do with the size of the wheel that you're actually turning compared to the size of the axle that's rotating. And if you think about a car, for all you auto peeps out there, I guarantee you the steering wheel that your hands are touching are larger, and they're a different size than the axle that's actually moving below your vehicle. Okay, there's a ratio there, and that ratio determines mechanical advantage. So see if you can find that. All right, if the textbook's not working for you and the PowerPoint's not enough information, pull up a internet page and type into Google mechanical advantage of simple machines, like I've done right here. And just by scrolling down, you can find all sorts of other great resources. Some of them are probably more informative than others, and some of them are probably more accurate. I definitely would trust anything from Khan Academy, Bozeman Science, that guy that does those podcasts from the University of Montana. CK12's not bad. I have never watched this organic chemistry thing, but maybe that one's good. Okay, so use your resources that are out there, collaborate with your peers, try to get these boxes all completely filled in, and then if that's done, all right, if your substitute, I'm not sure who's in the classroom today, takes a look at it, is satisfied with your work, and it's not just single word responses, feel free to go ahead and pull out our game if you want to practice with somebody, if you want to play just for fun. Just please make sure you're managing your time effectively and that all the pieces get put back in the Ziploc bag and back in the box and put back on the shelf there before you leave. I'd appreciate that. And I hope you guys have a great day. I will also be gone tomorrow, Friday. I'll have another short video for you regarding Friday, but I hope you have a fantastic weekend, and maybe I'll see you during parent conferences. Peace.